Okay, so for my video assignment today, I'm going to be breaking down ace and nitrile. Okay, awesome. So it can be written simply as CH3 CN. So by looking at this, I can draw a Lewis structure for it. So the Lewis structure for it would be so we're gonna have a bond right here, single bond between the carbon and the carbon. Carbon on the left here, it's gonna have single bonds to 3 hydrogens to fulfill its 4 bond requirement. And there's gonna be a triple bond between carbon and nitrogen with a lone pair here. So to draw this and show the atomic orbitals, I'll break down the structure and I'll show this bond between the carbon, and I'll also show the bond between the carbon and the nitrogen. I'll split it up so it's a little bit more clear. So with the carbon, we know it's going to be like this. So we'll go carbon here. And so this carbon on the left, because we know it only has single bonds, it's going to have an sp3 bond. So here, and then this carbon is going to have to bond with that as well. So it's one of the handshake bonds. This is going to be sp3, and then this carbon is going to be sp. I can explain that a little bit more later, but it's because it has a triple bond right here. So with that bond there, this carbon here has to make the bonds to the hydrogens, so that'll get represented with something like this. That's another sp3, and there'll be an S bond right there. So that's one of the hydrogen bonds coming off of that carbon there. Another one, sp3 with a hydrogen, which the hydrogen is just going to be an S bond. And then I'm going to attempt to draw it behind. It's going to be sp3 with an S bond right there. And so this is going to be this part of the atomic orbital structure. And I'm going to draw the carbon and nitrogen part of it right over here. So underneath, just make it a little bit easier. Carbon, nitrogen. So we know with it being a triple bond that it's not going to be just sigma bonds. There will be a sigma bond, however, there's also going to be pi bonds. So there should be, for this carbon here, there'll be two sigma bonds, 2 pi bonds for this carbon here. So we can start the sigma bond and the other sigma bond. And these are both going to be SPs. Okay. So the carbon's other bond, the other sigma bond, we know is already going to be fulfilled from here. That's going to be attached to that carbon. So this would be up there. I'm just writing it here to make it a little bit easier to focus on it instead of doing one big picture. So that would be, in reality, connected right up there. But they're going to have pi bonds. So the pi bonds are going to be oriented like this. Here. Trying my best, I'm not the best artist. Here we go. So that'll be our first pi bond, and then we can draw a second pi bond like this. So we have a pi bond going across the y-axis there. I'm trying to add a pi bond across the z-axis here. and then there we are. And so the nitrogen is going to have its lone electrons from one pair off to the side here. And then carbon, it'll fulfill its last requirement for the last sigma bond on this one here. So once those connect between them. And so that's how we draw the atomic polarized structure of acetonitrile, also known as CH3CN. Thank you.